Okay, we are still in 5.8 and we're going to go over 11 and 13. It says, um, indicate whether you would use the law of sines or the law of cosines to solve the triangles, then solve for the missing values. Okay, so the first thing I actually want to do, and I should have done this before I started this video, but nonetheless, that's okay. The first thing I want to do is I want to grab my law of cosines, because law of cosines is one that you guys are just learning right now. So there's the law of cosines. The law of sines is a little bit less cumbersome. It's right, sine A over A, sine B over B, sine C over C. So it says, indicate whether you would use the law of sines, law of cosines to solve the triangles, then solve for the missing values. So there's definitely an advantage, and this is what we were talking about at the very end of class, of using the law of cosines over the law of sines, because of this ambiguous case that we'll talk about right before the test. So here goes my interpretation of 11. Okay, so if I look at 11 and it says find the measure of angle A, B, and C, and they gave me 3 sides. So I'm going to look into the future. I prefer using law of sines, honestly, because it's an easier formula than all of this stuff, right? So I'm gonna attempt to use law of sines, and you'll see, oh, that's why she can't use the law of sines on this one. Okay, so the very first thing I do is I fill out the law of sines. The law of sines, if you remember, is sine A over A equals sine B over B equals to sine C over C, right? So that's the first thing that I notice. And then I'm going to plug everything in, and then you're going to notice something, hopefully. So let me make this a tad bigger. So the first thing I do is I'm going to plug everybody in. So I say sine A equals sine B equals sine C. And then A is 55.7 millimeters. B is 110 millimeters. And C is 118 millimeters. Okay, question. Do you remember why I'm calling this A? Do you remember why I'm calling this A? Why is this one A? Anybody remember this? Yes, very good. Opposite of big A. B is opposite of B. C is opposite of C. Remember, they just like looking at their little guys, right? So big C is across from little c, and so on and so forth. Okay, so does everybody see why law of sines took me to a place that I'm now in a dead end, right? This is a dead end. Why is this a dead end? Why is this a dead end? Yeah, it's I don't know over I know. I don't know over I know. I don't know over I know. So I would usually call one of them my helper. I don't have a helper here because I don't know. In every single case, I have something that I don't know. Okay. Give me a second. Okay, so I don't have a helper. So I'm going to move over to my other friend, which is called the law of cosines. So using the law of cosines is literally that. You just pick one and then you use it. So before we had just finished the area problems, there was literally one that you should use. In this case, there's not. There's not like, oh, you should use this one. There's not a case like that. So I'm just going to choose the top one just because it's the top one. And I'm going to copy that formula over here. And then I'm just going to plug everything in. Okay. So I use a squared equals to b squared plus c squared minus 2bc cosine a. And it looks like a mighty mess. But in reality, you're just going to plug everything in. Okay. So you're going to plug A in for A, B in for B, and C in for C. And then we're going to just continue. So that's 55.7 squared equals to 110 squared plus 118 squared minus 2 times 110 times 118 times the cosine of A. Notice A is all the way in there and he's stuck. So if you're saying, hey, Ms. Johnson, how do you get cosine? Your brain should already be asking, how am I going to get A out of cosine? And some of you already remember how to get A out of cosine, right? So I'm going to let this catch up to me so that you can see how I plugged in. There it goes. So I just literally plugged in A for A, B for B, C for C, B for B, C for C. Cosine A is still cosine A. And then I'm just going to simplify a bunch of people, and then we'll see how, like, what we can get. Okay. So here I go. I say 55.7 squared is 3,109.2 equals to, and then over here, I'm going to like math this. So 110 squared plus, oops, that's not what I wanted at all. Sorry, 110 squared plus 118 squared is 2,000, 26,024 minus, and then I'm going to go with 2 times 110. Man, Miss Johnson, you keep messing up. 2 times 110 times 118 is 25,960 cosine A's. Okay, so then look at this equation that I write right here. As soon as it pops up. There it goes. So then I'm solving for this. So I'm going to subtract this over and divide by that. This is nothing new. Don't get all confused because this is a cosine of A. You're still doing the same thing. I'm going to subtract 26,024, right? And then whatever I get there. So what is that? Next line. So 3109.2 minus 26024 is negative, which doesn't surprise me, negative 22914.8 equals negative 25,960 cosine A's, right? So then I'm going to divide by negative 25,960. So then we get cosine of A equals to whatever that is. So that's that negative, yeah. So then we're going to divide that by negative 25,960. So we get 0.88, whatever that is, right? Okay, how do you get A? How do you get A out of cosine? Yes. How do we get A out of cosine? How do we get A out of cosine? Yes, by using its inverse. By using its inverse. So as soon as this thing catches up to me, then I will take cosine inverse of both sides. Okay, so I will write cosine inverse here, and I will write cosine inverse here. There it goes. It's catching up. So because that number is this number, I can just, I don't know, I could just keep using this big O parentheses and layering this thing out. So cosine inverse, inverse. So according to this, the answer is 28.03. So A is approximately 28.03. So this guy in here is 28.03. I'm liking this answer. Okay. I'll tell you why I like this answer. I believe that I did it right. Because number one, you all were watching me not make a mistake. I don't know. You guys are good at telling me, Ms. Johnson, stop, you made a mistake. Right. But this angle in here, not saying that it looks like 28 degrees, but it's a small enough angle that's across the smallest side. Remember we talked about this before? We talked about how the smallest angle always needs to be across the smallest side. So now you're like, yay, Miss Johnson, we did that. Oh my gosh, Miss Johnson, are we going to have to do that 2 more times? You can, but you don't have to. Okay, there is another way to move right now. Now that I have an angle, I'll scroll up just a tad for a hint. Now that I have an angle, is there another way for me to go besides jumping to, b squared equals a squared plus c squared minus 2ac cosine b? Yeah, I can jump over here to the law of sines. Why can I now use the law of sines, but before I couldn't? Right? Now I can because I have A. So this guy's going to be my helper, isn't he? So I'm going to pause really quick so you guys can try that. If you like using cosine, the law of cosines, do it. If you don't like using the law of cosines, jump over here to sines, law of sines right here. But I'll be right back. Okay, so if you tried law of sines, which I am going to do right now, you'll see that your answer will be the same even if you use the law of cosines. Okay, so I'm going to pull this over here and I'm going to write, I'm going to find sine of A, which is 28.03 over A, which is 55.7 equals to sine of B over 110 millimeters. And I'll leave my millimeters in there. They'll get lost eventually. Oops, you can't see what I'm doing. Okay, so once I had my equation, which basically looks like this, sine of 28.03 equals to 55.7 over this, right, equals this. Then I need to solve for B, so I'm going to multiply both sides by 110 as soon as it shows up. Are you going to show up, buddy? It is not showing up. Okay, I'm going to pretend you can see this, okay? And then you multiply by 110 on both sides. So you'll see me multiplying by 110. So then I will get what? I will have sine of B. Oh, there it is. I have sine of B, and then I have no more of this 110 because it divided out. And then I have this thing. So I get 110 sine 28.03 all over 55.7, right? So then how do you get B out of sine again? How do you get B out of sine again? Very good. You use the inverse. So I'm going to scoot this guy over, and then I'm going to inverse both sides. And then you will see it. It is not going to show up anytime soon. Let's see if it'll go faster if I do this. All right. What did I do? Okay, he's still there. I don't know what's happening. So I'm going to type it in here so you guys can see it regardless. So here I would use sine inverse. So sine to the negative first of, and I do big parentheses here, right? So I have 110 sine 28.03, right? Divided by 55.7. Okay. So according to this, my B, oh, there it goes. Sine inverse. Okay. So according to this, B is about 68.13. I don't know. B is about 68.13 degrees. So I write that there. Okay. So then you'd say, oh my gosh, Miss Johnson, I'm going to have to do that again. You tell me, how would you find C? How would you find C after all that we've done so far? What would you do to find C? Very good. You are remembering that all three angles, perfect. All three angles add up to 180. So I'm just going to subtract them both. So 180 minus 28.03 minus 68.13 gives me 83.84. So here's another random check for me. My random check is that the longest side is across from the biggest or largest angle. That's true. My smallest side is across my smallest angle, and medium is medium. So this is kind of like Papa Bear gets the biggest chair, Mama Bear gets the medium chair, and Baby Bear gets the smallest chair, right? It's the same kind of thought here. So whenever you're doing a problem that looks like this, you don't have to use this thing over and over again. You could, like literally you could. There's nothing wrong with it. But there's a couple of shortcuts that I'll introduce you to so you feel a little bit more comfortable, right? Okay. If I was going to do 13, which I'm going to, I notice here now, again, because I could look into the future and I know what's about to happen, right? If I filled out sine A over A, sine B over B, sine C over C, you would see some interesting things happening, very similar to what we did up here, where I didn't have a helper, right? I didn't have a helper. So if you don't believe me, that's okay. Just go ahead and like plug all that in and make sure that you understand that. But I am going to be using my law of cosines for this one, right? So this one does actually matter which one I choose. This one, I'm gonna tell you right now, I am going to use the law of cosines. And it does actually matter which one I choose. So which one should I choose? Should I use 1, 2, or 3 for this one here? Yeah, I'm going to use 3 for the same reasoning as before. Because they gave me angle C, I'm going to find the one that has angle C in it. So I'm just going to plug this in again. So it goes C squared equals to A squared plus B squared minus 2AB cosine of C. Okay. You'll see a pattern. Eventually, you guys will see a pattern on why this is called the law of cosines. You can kind of see the Pythagorean theorem right here ish, and then some extra stuff there, which makes sense if you think about it because this is not a right triangle. Okay, so then all I'm going to do is I'm going to plug in everybody. So then C squared is, I don't know. A squared is 19 squared plus B squared is 14 squared minus 2 times 19 times 14 cosine of C, which is 52 degrees. So this thing is straight plug-inable, right? I'm just going to straight plug this whole thing in. There's nothing that I'm solving for. C is actually what I'm looking for. So I'm going to plug this whole thing in. It's going to take me a second. So while my computer catches up to my writing, I'm going to move on. Oops. Plus 14 squared minus 2 times 19 times 14. Look, it caught up. Cosine 52 degrees. I think this is already on degrees. It is. So that's 229.47. 229.47 equals C squared. So far, so good. Everybody okay? Any questions so far? You guys okay? Okay, perfect. Okay, so then I put that there. How do I solve for C? How do I solve for C? Now that I have C squared equals to all that, do you all remember this? How do I solve for C? What do I do? Yeah, we square root both sides. Very good. Go ahead and square root both sides. And I'm going to remind you, don't forget the blank or the blank, right? This is what Miss Johnson always does. Square root, square root. I say don't forget the plus or minus here. But we take out the minus because we're talking about sides of a triangle, right? So whatever that is, I'm going to be slick about this. So I'm going to put this whole thing in parentheses and I'm going to do square root. It's not going to let me do that. That's not good. All right. So I'm just going to use another line. So square root of 229.47, right? That's what I said. So it's about 15.15. C is about 15.15. Right? So there it is, 15.15. That's what I put over here. And they still want you to find the other angles as well. So now that I have this, you have choices. Do you want to go over here and use the law of cosines, or would you rather use the law of sines? That's always your choice. So after you use the law of cosines once, now you have enough information to go back to law of sines, which is always going to be my preference because now I have a helper. You see my law sine C over C. I have a helper. So that's what I would move towards next. If you want to use the law of cosines to verify, you can always do that. But I'm going to go over here and I'm going to put sine of 52 degrees over 15.15 yards is equal to, let's do sine of A over 19. So then I'm just going to solve this equation that you can't see quite yet for A. So you're thinking, how do I get rid of sine? You've said it several times, so I think you guys are comfortable with it. But first I need to multiply by 19, right? So then I get 19 sine 52 over 15.15 equals to sine A, right? And then I'm just going to ask the same question. How do I get A out of sine again? What do I need to do to get A out of sine? And you guys are like, oh, use the inverse. So I'm going to use the inverse, and you're going to see it, sine inverse of this whole thing. So A is approximately, and then I plug this whole thing into the calculator, right? So I go sine to the negative first, parentheses of 19 sine 52. Do you notice right now, because I'm not done plugging everything in, do you notice how it says undefined? It's undefined because that angle doesn't exist. But then once I divide this by 15.15, then the angle does exist. It's 81 degrees. So the A is about 81.21 degrees. And then I plug that into my diagram, and I'm pretty satisfied because I'm like, oh, my diagram is looking pretty good. This is looking medium. This looks like the largest side, which I'm getting 84 degrees or 81 degrees, 81 degrees, right? And then you would just use, triangle angle sum to find my third angle, and then I'm done. So 180 minus 52 minus, 81.21 gives me 46.79. And then there's my answer. So I'm going to recap really quick. Miss Johnson, because she likes using the law of sines, will tend to use and check law of sines first. In these two examples, we did not find a helper, right? We didn't have both pieces of information in a ratio, so I couldn't use it. I used law of cosines to then find my angle. And then once I find my angle, I jumped back to law of sines. If you wanted, you could use law of cosines every single time, and then you should have come up with the same exact answer. So same thing goes here. I tried this one, and I plugged. I in my head I plugged in the law of sines, and I said sine of C over C. That doesn't have it. That's not my helper. Sine of A over A. That's not my helper because I didn't know this. Same thing with sine of B over B. And then so because I couldn't use law of sines, I jumped over to law of cosines. This one actually mattered which one I used. So I had to use this last one because they gave me sine. They gave me angle C. So once I figured that out, then I just plugged everything in. And if you notice, this is, I called it plug-inable. You just literally plugged in everything. And then you found the square root. And now you had a helper, right? So then I jumped back over to law of sines and was able to do it this way. I will tell you the thing about using the law of cosines and the law of sines is at first it seems like, oh my gosh, which one should I use? If you don't know, do the same thing that I do. Try law of sines. I don't have a helper. Then jump over to cosines, then jump back over to law of sines, right? Hopefully this helps you. Appreciate you listening. Have a great day.